Hello everyone. This section is the final part for introducing the conservative force. Okay, in previous two videos, we just introduced the force, the elastic force or spring force, and the gravitational force are conservative force because the work done by that two kind of force is uh, only cares about the initial position, final position, independent to path. Okay, so this that two kind of force is the conservative force. And the last one we just introduced what is non-conservative force. Okay, a non-conservative force, the very vivid example is the friction force. Then suppose we have an object moving on rough surface, and the surface it had moving along three different paths A, B, C. And this graph is a top view. You view from the top, okay, view from the sky, and you view from the sky, okay. Object moving this along these three paths, okay. And when let's suppose yeah, we don't have. Oh, okay. No, not suppose. We just suppose the friction force is 5 Newton. And let's calculate the paths. Let's calculate the work done by the friction force along these three paths. Okay. And how to calculate the work done by a friction force? We will use this formula and the friction force. Okay, friction force. Okay, and friction force because opposite. Friction is always opposite to your moving direction. So um, the force, the work done by a friction force is always okay. That's friction. That's friction is always, and I just like to put a negative in front of the name, and it's a friction force. Friction force times the uh, distance because the friction force is always opposite to your moving direction. So actually, there is no direction issue when you calculate the work done by a friction force because it's always negative, always opposite to your moving direction. So it's always the inner product always 98. The cosine theta is always 180 degrees. So it's always negative, and so it's always negative, and always there is no direction issue. Okay, so the work done by the friction force is friction force times the distance. Okay, so if you understand this, actually this problem is very easy. Okay, let's calculate the friction force in path A. Okay, so it's minus 5 times the distance of A. Okay, now what's the A? Okay, so let's suppose that this is 90 degree here. So what's the distance of A? Know how to calculate I square plus C square. Okay, so what's the value of this? Okay, let me calculate the value. 30 plus 9, 34 square roots. So, and times 5. So, it's minus 29.15 joule. Okay, okay, 4. Okay, okay. So, WB, let's see, pass B. Okay, minus 5 times the distance of path B. Okay, minus 5 times. So here is 653. So 653. Okay, 653. Okay, so 6 times 653. 6 plus 5 plus 3. Okay, and 5 Newton times 5. Okay, let me see. 6 plus 5 plus 3. Okay, times 5. So it's minus 70 joule. Okay, so for these two calculations, pass A and pass B, yeah, they have the same pass A and pass B, they have the same initial position, final position, but the work done by the friction force, you see, it's upon path dependent. Okay, so although they have the same initial and position, final position, but you see the force, the work done by friction force. It's nothing to do with your initial position and final position. It care about which path you are, which path you are taken. So let's see. Okay, what's the C? Path C. Path C. Okay, it's minus 5 times dc. So it's minus 5 times dc is 5 plus 3. So it's minus 40 joules. So these three paths, they all have the share the same initial position, final position, but they are different paths. You see the friction force on different paths. The work done by friction force on different paths has different values. So it's path dependent. Path dependent. Okay, let's say make a mark here. Path dependent. Dependent. And so friction force is a non-conservative force. Conservative force. Conservative force. Okay, so that's why friction force is a non-conservative force. And you look at it's always negative. It's always the work always negative. It's different from the example we demonstrate in the spring force and gravitational force. In spring force and gravitational forces, it sometimes do the positive work, sometimes do negative work in elastic and spring force and gravitational force. But for friction force, it always do the negative work. Okay, that's also a very important difference between a conservative force and non-conservative force. Okay, for this friction, if you seems to not quite understand this, so let me show you a little about this. Okay, suppose we have the object moving on a flat surface, right? So we have friction force. We have friction force here, and always if it's moving in this direction. Suppose the object moving in positive direction, and the friction was always negative direction. Okay, so let's see. I suppose we have a tiny work done by the friction force. A tiny work done by the friction force. Let's see. Tiny work done by the friction force. Okay, that's friction. Tiny work done by friction force equal to the force times displacement. The friction force, okay, dot product to the displacement. Okay, delta, should I use this? Delta R. Okay, and because we are only in the positive direction, so let's say delta x vector, and because tiny means delta x, so let's put delta x. Okay, so then the friction force, okay, tiny friction force. Okay, so let's say it will become the magnitude of force. Let's say the force is Fk is equal to vector is Fk and minus Fk and sorry Fk. This is this is negative in the I. Okay, so negative I dot delta x I. Okay, so it's I dot I, so it will become 1. So small friction is equal to minus Fk dx. Okay, so I dot I will become 1. And so, and then we do the both integration to both sides, integration to both sides. So left will become the work done by friction, and the right will become suppose the force of the suppose this the constant friction force. Okay, as if k delta L. So this will become the distance. Okay, so we add a tiny delta x together, and regardless of its direction, that will become at minus a times distance. Okay, so that's very short proof. If you are if you are very wondering about where this comes from, that's a very simple proof here. Okay, okay, so okay, this is, and the final one is add small delta x together, and you add all the distance. If add all the delta x together, you become the distance. Okay, hope you can understand this. Okay, okay, we'll start the video here, and hope you understand the difference between the constitutive and non-constitutive force. Okay, see you in the next video. Bye bye.